Pakistan-China military relations are extremely close. Together, they developed the JF-17 Thunder fighter, and India is very wary of this relationship. According to Defense School, Russian Klimov Design Bureau is developing a new engine for Pakistan JF-17 fighter called the RT-93MA. The engine has entered a testing phase to confirm its performance under simulated flight conditions. It is expected that the RT-93MA engine will be tested on fighters by the end of this year. That means JF-17 Thunder Block 3 will be tested with RT-93MA engine in early 2021 or 2022. Is expected to significantly increase the performance of JF-17. The JF-17 Thunder or FC-1 Xiaolong is a lightweight, single-engine, multi-role combat aircraft developed jointly by the Pakistan Aeronautical Complex and the Chengdu Aircraft Corporation of China. The JF-17 can be used for aerial reconnaissance, ground attack, and aircraft interception. Its designation JF-17 by Pakistan is short for Joint Fighter 17, while the designation and name FC-1 Xiaolong by China means Fighter China 1 Fierce Dragon. The JF-17 was primarily developed to meet the Pakistan Air Force requirement for an affordable, modern, multi-role combat aircraft as a replacement for its last squadron of Dassault Mirage 3 fighters, Nanchang A-5 bombers, and Chengdu F-7 interceptors. For China, JF-17 Thunder multi-role fighter is one of the country's most successful aerospace exports, has the potential to be a cost-effective and competitive alternative to more expensive Western fighters. By 1989, because of economic sanctions by the US, Pakistan had abandoned Project Sabre-2, a design study involving US aircraft manufacturer Grumman and China, and had decided to redesign and upgrade the Chengdu F-7. In the same year, China and Grumman started a new design study to develop the Super 7, another redesigned Chengdu F-7. Grumman pulled out of the Super 7 project in 1989 due to Tiananmen Square and the resulting fallout. The project remained on ice for around 10 years as negotiations between China and Pakistan continued. A feasibility study to see if future development would be fruitful was commissioned in 1992. It was successful, so a memorandum to continue development was signed. In 1998, China and Pakistan recommend serious development of the Super 7. Cost was split 50-50 between the Pakistani government and CAC, and the aircraft was renamed JF-17. As Grumman has dropped out, the fighter needed a new power plant. A solution was found in Russian Mikoyan Design Bureau, which offered the Klimov RT-93 engine, which was originally designed for the cancelled MiG-33 fighter jet. The RT-93 was an advanced version of the RT-33 used on the MiG-29. However, only one RT-93 is used on the JF-17 in contrast to two RT-33s in the MiG-29. Another key innovation that occurred during the development process was the inclusion of diverseless supersonic intakes on the JF-17 design. The design went through several iterations, but is seen on current JF-17 production aircraft. In 2003, the first prototype took to the air. By 2006, the JF-17 was finalized and ready to enter serial production. It was formally adopted in 2007. The first fully Pakistani manufactured JF-17 was created in 2008. The airframe is a semi-monocoque structure constructed primarily of aluminum alloys. High-strength steel and titanium alloys are partially adopted in some critical areas. The airframe is designed for a service life of 4,000 flight hours or 20 years. the first overhaul being due at 1,200 flight hours. The retractable undercarriage has a tricycle arrangement with a single steerable nose gear and two main undercarriage. The hydraulic brakes have an automatic anti-skid system. The mid-mounted wings are of cross-delta configuration. Near the wing root are the leading edge root extension, which generate a vortex that provides extra lift to the wing at high angles of attack encounters during combat maneuvers. A conventional three-plane empennage arrangement is incorporated with all moving stabilizers, single vertical stabilizer, rudder, and twin ventral fins. The glass cockpit is covered by a transparent acrylic canopy that provides the pilot with a good all-round field of view. It has three large multifunction color display and smart heads-up display with built-in symbol generation capability. A center stick is used for pitch and roll control, while rudder pedals control yaw. A throttle is located to the left of the pilot. The cockpit incorporates hands-on throttle and stick controls. The pilot sits on the Martin-Baker Mark 16 LE00 ejection seat. The cockpit incorporates an electronic flight instrument system and a wide-angle holographic head-up display, which has a minimum total field of view of 25 degrees. As mentioned above, JF-17 is equipped with a clean of RT-93 afterburning turbofan, creating a dry thrust of 50.4 kN and 85.6 kN thrust with afterburner, making the aircraft can fly at a maximum speed of Mach 1.6. The range and service ceiling of the aircraft are 2,500 km and 16,500 meters, respectively. The aircraft weighs around 6.5 tons, and its maximum takeoff weight is 12.7 tons. The JF-17 can be armed with up to 4.6 tons of air-to-air and air-to-ground weaponry, and other equipment mounted externally on the aircraft's 7 hardpoints. One hardpoint is located under the fuselage between the main landing gear, 2 are underneath each wing, and 1 is at each wingtip. Internal armament comprises one 23mm GSS-23 twin-barrel cannon mounted under the broadside air intake, which can be replaced with a 30mm GSS-32 twin-barrel cannon. The aircraft is fitted with PL-12 or SD-10 radar homing medium-range air-to-air missile, unguided bombs, satellite-guided bombs, gravity bombs, anti-ship missiles, anti-radiation missiles, rocket launchers, and a laser designator port. The JF-17 is equipped with AIM-9L, PL-5E, PL-9C short-range air-to-air missiles on its wingtip hardpoints. The JF-17's designers have proven adept at keeping up with the times following its entry into service. The initial run of fighters for Pakistan have been referred to as Block 1 JF-17s. Block 2 JF-17s introduced a multitude of new capabilities and upgrades, including composites in the airframe for reduced weight, air-to-air refueling, a full fly-by-wire system, and a better radar. China offered to replace the Russian RT-93s with their WS-13 in Block 2 JF-17s, but Pakistan opted to stick with the Russian engine. For the Block 3, China hopes to add an AESA radar to the JF-17 and further improve the avionics and weapons compatibility of the JF-17. The standard JF-17 features the MIL STD-1760 database in some implementation, allowing for compatibility with Western and Eastern weapons. The largest advantage of the JF-17 is its cost, at only $15 million per plane in its most basic configuration. The JF-17 is far cheaper than any of its competitors, even used. Block 2 JF-17s cost around the same margin, with Myanmar buying them for only $16 million per unit. This has been the key to the JF-17 export success. A poor nation can fail a relatively modern fighter for a very low price. It is yet to be seen whether it can actually perform at its price point in combat, but Pakistan seems to be satisfied with what the JF-17 can do in trials. In many ways, China has updated the biggest fighter of the last generation, the MiG-21, for the modern era with the help and additional design cues from the F-16. My video about JF-17 Thunder has ended here. Thank you for watching. If you find this video interesting, please give me a thumbs up. Don't forget to subscribe to support the channel. Thank you very much.